Hey guys, today we're looking into how Peloton creates workout recommendations with AI and the platform they actually have set up. They have multiple interesting things here, like how they do the recommendations, what tools they use on AWS, a graph database, DynamoDB as a document store, a model registry for the AI models, and then here's something for the training of the AI. Very interesting, so have fun.
Don with AWS.
Hi, I'm Vijay from Peloton, and this is my architecture.
What do we see here? EKS, so Kubernetes, graph database, Dynamo, something with models, S3, EMR, EKS. Okay. Cool. That looks fun.
So Vijay, as an active rider, had a Peloton for about 6 years. Really excited to talk about your architecture that you have here today, the recommendations that I've always wondered, how do you know what I like? I'd love to learn more.
As you may know, Peloton is the leading connected fitness company that currently has over 8 platforms where members actually can take workouts at the convenience of their home.
They started with
we have
bikes,
over
I think.
6.5 million members today. We have had over 1 billion workouts on the platform, so we know a lot about our members and their preferences, and we typically use a lot of that information to power their experiences on the platform itself. In order to do that, today we actually build large-scale recommender systems that are powering a lot of the personalization experience that you see on the platform.
Cool.
So across those 8 platforms, I have to imagine the recommendations are very different based on data and the frequency of the data and the frequency of the rides, if you will. Can you walk us through the model?
It's also not just rides, right? They are. What can you do? You can row there. You can do running now. You can do rides like on the bike. I think they have a lot. By the way, if you want to learn how to create platforms and pipelines like this, then I have the right thing for you. In my data engineering academy at learndataengineering.com, we now have roadmaps for beginners, for analysts, for scientists, also for software developers, and a Spark and Apache Kafka bootcamp. There are also more of these roadmaps coming. And to celebrate this, we now give for this week only 20% off for the annual and unlimited access. Use the code ROADMAPS2025 for this. Yeah, I think this will help you a lot. So check it out. And now let's continue with the video.
All training, what goes on behind the scenes to actually prepare the data?
Sure. So today we train our models once a day. That is done in an offline batch process where we take a lot of our historical data that we know about our members, which is currently stored on S3. We take that data, we pre-process that data and using Amazon EMR clusters, which runs Spark jobs. Once we pre-process the data, we use that data to actually train our models itself, which is again run on an EKS cluster, which hosts some of our GPU instances. Once we train these models and we are comfortable with the performance of those models, we actually push those models into our model registry, which stores the model artifacts itself.
And do you use anything for ML ops or anything behind the scenes to manage that?
So pretty straightforward, right? You have your stored data that you train your algorithms with in S3, a lot of data from sessions. Then through EMR, you pre-process that data, and then you train your models on that data. This is a cool use case, and actually, using the model registry then to actually handle the models, that is a nice way of doing it.
The model artifacts itself.
And do you use anything for ML ops or anything behind the scenes to manage that flow?
So we do, and we currently, all our jobs are orchestrated using Airflow that is actually managed on MWA.
Yeah, MWA is the managed workflow, managed Airflow on AWS. So basically this here, let's quickly...
Performance of those.
Or was it here? So basically this process here of the training, this is like the pre-processing and then the training. This is done with Airflow. Right? So nice. Okay.
It is actually managed on MWA,
Okay.
which is again a managed AWS service.
Yeah.
Great.
This makes
And
sense
as
to
far
use.
as the data that you have, I see a graph database and we have DynamoDB with a feature store. Can you talk about the data and how you process that?
In order to support our real-time inference, we have a couple of low latency data stores that support our inference in real time. The two of them that you're seeing here, one of them is the graph database, as well as the Amazon DynamoDB, which actually hosts all our features that are necessary for scoring our models.
Okay.
These stores are
So for scoring models, for training models, scoring, when these models run.
actually
Okay.
powered by EMR jobs that are run that populate all the historical information that is necessary for scoring the models itself. So both these stores are actually populated using the Spark jobs that are run on EMR clusters.
Okay. So that is all based, let's say, metadata for the training, right? This comes all into these databases. They're not used for the user data or something.
So both these stores are actually populated using the Spark jobs that are run on EMR clusters.
Okay. And just, from my understanding, what type of data are we talking about? What's in the graph? What's in the feature store?
Sure. So the graph hosts a lot of the information about the members, as well as the rides that they have taken on the platform. So if you have taken a class recently on the platform on the bike, that becomes an edge on our graph database. We leverage that information a lot of the times to power a list of candidates that is necessary for scoring the models itself. Now, in terms of the feature store, as you are aware,
so you see, this is basically metadata here that you use, as I said, for scoring the models then later, right? So this is the metadata that, or the metadata. Is that metadata called users metadata? Historical data. This is the most likely, or is this the current data that they're using? But let's just hear it.
Machine learning models need a lot of the data that is pre-processed in a way that can be used to score our models as well as train the models. The feature store hosts a lot of that information. Some of them includes historical information about your behaviors on the platform, the instructors that you might like, the durations that you might like, or the fitness disciplines that you might like. All of that is basically stored in our feature store.
Great. That's super helpful. I know as
and with that they can then also score the models, how good they would predict, and they can see what you're actually doing. Like they would predict what you're doing tomorrow, and then, or how your journey will conclude or will go on, and they can test it then with actually when they build the models.
as a rider, when I come in and you know exactly which instructor, the length, the type of music I like, that's very helpful. Time saving. So let's walk from the perspective of the bike, right? So if you could describe kind of what's on the bike and then how you're interacting with the hydration service and the rest of the services here.
So when somebody tries to get on the bike and start a workout on the bike, the call comes to a backend service, which we are calling that as a hydration service that is typically used to hydrate the recommendations. The hydration service calls our recommendation service, where you can think of this service as an orchestrator service that typically orchestrates all the information that is necessary to generate the recommendations itself. So for example, it makes a call to the feature store to fetch all the features that are necessary for this member. It also fetches a list of candidates from the graph store itself that is necessary to populate the recommendations. It also fetches the latest model that is necessary and to score the recommendations itself. All of that information is now passed to the inference service, which takes in all the information, scores the model against all those candidates that we have fetched, and then returns a list of scored classes that the recommendation service can actually now return back to the hydration service. Once the hydration service receives the recommendations, then the hydration service sends the recommendations back.
Wow. Okay. And there's a lot happening in a very quick time, right? Because this needs to go very fast. So it's getting you the, let's say, the metadata data about you, about your trainings. It's getting a model that you for the prediction or for the recommendations. Then this is actually starting the task of getting you the results or getting you the recommendations, and then boom, 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 boom. Wow. Okay. That's awesome.
Okay. And then MSK, event logging, what events are being emitted and what do you do with those events?
The recommendation service, which is the orchestrator service, fetches all the information before it sends the recommendations back to the hydration service. It logs a lot of the information, and we use a lot of this information for our training purposes also.
So as you can see, this, as I said here, this recommendation service, this is actually the orchestrator, right? This one is the one that is getting the data out of all these resources, and that is then starting actually the process of getting the or generating the recommendations for you. This is all on Kubernetes, built in a containerized environment, and that sends statistics then into MSK. What do they write here? The key benefits of moving away from a batch inference to a real-time inference are that members can see contextual recommendations tailored down to the time of the day. From an operational standpoint, Peloton has also seen cost savings benefits because they are now only generating necessary recommendations at the time of the request. Of course, that makes sense. That was something I was thinking first about, like if they are, like, why are they doing this on the fly? They could do this for every member, like pre-processes. Oh, but of course, then you can't act, or that you can't act on the time of the day. Right? Make specific recommendations for now. And because it is a live recommendation, it can very quickly generate you the results. Wow, that's cool. Most likely they use here APIs, right, to send the data back and forth, because here's also, this is an API here on the left. Wow, okay. I think that's a cool use case. It would be interesting to see a bit more about these two here, what is in there, but I think they explained a bit what this is about.
So this gets stored into S3, which is further used for training our models.
Okay, so that becomes a feedback loop for the entire system. Well, thank you, Vijay. I really appreciate you sharing your architecture today.
Awesome. Very interesting. I feel this is very interesting. I love these kind of things. Somebody asked before if there are some architecture reviews for Azure. I don't know any. Like, I don't know. I haven't seen this before with other platforms. I know just the AWS, they have this as their own YouTube channel, but I don't know anybody else who does this. All right. That was it for today. Thanks for being here. See ya.